We're going to look at number 10 and number 16 on 2.5, and I want to point you towards page 95 in the textbook, and it talks about how to go about these types of problems. Essentially, we're looking for the end behavior of the function. So we're looking kind of for any horizontal asymptotes that might occur, and there's a couple things from college algebra we might remember about the power of the numerator and the denominator. But one thing, when that's not clear, like in this example, what we're going to do is we're always going to divide the numerator and denominator by the highest power of x that shows up in the denominator here. So on this problem, the highest power of x in the denominator is x squared. So we're going to take the limit as x goes to infinity of the square root of x cubed plus 4x plus 9 divided by x squared divided by 4 minus 5x squared divided by x squared. And in this case, we're going to note we can write x squared as the square root of x to the fourth. And in this case, since x is going to infinity, x is always positive, so we don't have to worry about any absolute values here. That's kind of nice. The reason why we use this is we can pull that up into the under the square root. So here I can replace x squared and write that as the square root of x to the fourth. So on my next simplification, I can write x cubed plus 4x plus 9 divided by x to the fourth all under the square root. And then here I would have 4 over x squared minus 5. And it turns out that each one of these terms can be simplified. If I go one step more, I'd have the square root of 1 over x plus 4 over x cubed plus 9 over x to the fourth divided by what I had up here. Essentially, if I let x go to infinity, this term's going to go to 0, this term's going to go to 0, and this term's going to go to 0. The square root of 0 is 0. And in the denominator, I have 0 minus 5. So I have 0 over minus 5, which is going to 0 here. So it turns out the horizontal asymptote in this function is at y equals 0. So the limit as x goes to infinity would be going to 0. So I think on yours you were dividing by this x cubed, and that's the highest power of x in the numerator, but not really, because really this is x to the 3 over 2. So hopefully that kind of clarifies what's going on there. And then on the trig function, so the limit as x goes to any point in sine is going to equal the value of that point in sine. However, the end behavior, since sine is periodic, that it's going to oscillate in between plus or minus 1 the whole time. So this graph here is going to oscillate between plus or minus 1 the whole time. So if I take the limit as x goes to infinity, there is no asymptote. There's no end behavior. So that is why the function does not exist at that limit. So visualizing the graph, you can see it doesn't tend to anything. It's periodic, so therefore there's no limit at x goes to infinity or x goes to minus infinity. I'm going to oscillate between plus or minus 1 the whole time. But if I wanted to say the limit as x goes to 0 of sine of 3x, that's just going to be sine of 0, which sine of 0 is 0. So there's some things to keep in mind there. The end behavior is a little bit different than the limit at a point. It is a continuous function, but it doesn't have an asymptote. It doesn't have a horizontal asymptote.